Moving on, let's see how to do the current or how to measure current using the ammeter or the analog ammeter that we have here. So again, using the same scale, I have placed here the numbers 1, 3, 5, 7, 9, and 10 on the scale. Let's start with the easiest. We will be pushing the button here. We have to push it in so that we can be using the current, or we may use the current. And we have to read from 0 to 10 because I put here the selection to 10 milliamperes. Remember the unit, it's 10 milliamperes. This represents the limit or the maximum current that we can measure. And on the right side, there is a guide here that is also the same 10 milliamperes. Now, each of the secondary division here, the small lines here at the bottom represents 0.2, and the longer lines at the bottom represents 1 each. Therefore, this is 2, this will be 3, and so on until you reach 10. And remember to push in this button so that you may use the current meter or the ammeter, because if you don't push this button, then it will be still in the voltmeter function. And you have to consider that the DC current limit is 10 milliamperes, and we have to read from the bottom 0 to 10. Now let's start. Let's do the same readings before. Again, it will be the same 0.2 milliampere. Not really the same, but in the beginning, this is not 0.2. It was 0.5. But that is if you're looking at the top. Now, we will not look at the top scale. We will not use 0.5 here. Instead, you have to go down here, and as mentioned in the guide, this will be 0.2. Therefore, if the pointer is there, that will be 0.2 milliamperes. Now, to continue here, we have the reading of 0.2 milliamperes or 0.2 milliamperes. It's so easy. And the next one is between 0.2, 0.4, 0.6, 0.8, and 1. So it's between 0.8 and 1. So again, this is 0.9, but this time we will put milliamperes, MA, because we are using the current meter or the ammeter. Do not put voltage here. And we don't multiply or divide anything because the value of the limit is 10, and the number in this scale has a limit also of 10. Let's move on with number 4. What do you think will this be? 2, 0.2, 0.4, 0.6, 0.8. So this will be 2.8 milliamperes. The next one, 6, 6.2, 6.4. So this will be 6.4 milliamperes. How about the next one? It's exactly on the 7, so 7 milliamperes. And then we have 8.4 milliamperes over here, and the last will be 10 milliamperes. So I hope you understand, and let's try another one. So we try the 10 milliamperes, so we already know how to read the normal way from 0 to 10. Let's move the scale to 1 milliamperes or 1 milliampere limit. What will happen if we choose the 1 milliampere limit? Of course, the limit is 10. So to get 1, we have to divide our answer by 10. Let's try the first example. We will still be reading from 0 to 10. We will still be using 0.2 each for the secondary division, meaning the small lines will still be 0.2 and the long lines at the bottom will still be 1. Now, we will push in still the push button here, and so the first one will still be 0.2. it will still be 0.2, but this time we will divide it by 10. Why? Because you put your selection to 1 milliamperes or 1 milliampere. That's the rule here. We have to divide it by 10 if you put it in 1 milliampere. So the next one will be zero point 0.9 divided by 10. That will be 0.09 over here. Because this is zero point 0.2, zero point 0.4, zero point 0.6, zero point 0.8, and 1. It's between zero point 0.8 and 1. So it's zero point 0.9 milliampere. This is 2.8 milliamperes, but divided by for number 3, let's go back to number 3. I think I said zero point 0.9 divided by 10, that will be 0.09. And number 4 is 2.8. 2.8 because this is zero point 0.2, zero point 0.4, zero point 0.6, zero point 0.8. 2.8 divided by 10, 0.28. So that's the rule that you should not forget. 6.4 divided by 10, 0.64 milliamperes. 7 divided by 10, that will be 0.07 milliamperes. Number 7, 8.4 divided by 10, that will be 0.84 milliamperes. And finally, number 10 here, divided by 10, will be equal to 1 milliamperes, which is exactly the same with the limit that we have here. Therefore, if your answer here will be 10, you will be wrong. If you write 30, you will be more wrong. And if you write 100 wrong, 300 is wrong. The answer must be similar to the limit here, which is 1. So to get that limit, you divide by 10. 10 divided by 10, that will be 1 milliamperes. Let's try another one. This time, let's think of, instead of thinking 1 milliampere, let's try 1000 milliampere. 1000, no, I'm sorry, 1000 microamperes. Therefore, this is hard because we will be thinking that the limit will be 1000 microamperes. But we don't have 1000 here. What we have here is only 10. And so, to get 1000, we have to multiply this by 10? No, because if you multiply by 10, it will only be 100. If you multiply this 10 by 100, then that's it. We will be getting 1000. So all the readings that we will do will be multiplied with 100. So this is the DC current connected to 1 milliampere, but this time we will be thinking of the 1000 microamperes limit. So we will still read from 0 to 10, and we will not imagine it as any number, but we will just read it the normal way, like what I have told you before, but we have to multiply our answers with 100. So let's try the first. Again, 0.2 and 1 each. So this one will be 0.2. Multiply with 100, that will be 20 microamperes. The second one, 0.9, multiply to 100, 90 microamperes. The third one is 2.8 multiplied to 100. We will get 280. Again, as you can see, for number 5, look, 6.2, 6.4 is still the same, 6.4, but because you put it into the 1000 microamperes limit, we have to make the 6.4 multiplied with 100. And so, our correct answer reading will be 640 microamperes. The next one is 7 multiplied with 100, 700 microamperes. Number 7 is 8.4 multiplied to 100, 840 microamperes. And finally, 10 multiplied to 100, that will be 1000 microamperes, which is exactly the limit for our chosen selection here, which is 1000. I hope that's clear. Again, if you still don't understand, you can repeat watching this video. Now, moving on, let's move the selection to the first one here, which is 0.1 milliamperes or 0.1 milliampere. So again, still the same, zero point 0.2 each and 1 each for the major division. So we will still get the zero point 0.2, but this time we have to divide our answer by 100. How or why? Because 10 cannot be our limit. Our limit must be zero point 0.1. So how will we make the 10 to become zero point 0.1? We have to divide it by 100. So if you divide 10 by 100, you will get the limit of zero point 0.1. So everything that we will measure here will be divided by 100. So let's look at the third. Again, it's zero point 0.9 divided by 100. We will be getting 0.009 milliamperes. We will get 2.8 divided by 100, 0.028 milliamperes for number 4. For number 5, it will be 6.4 over 100, 0.064 milliampere. We have number 6, 7 divided by 100, 0.007 milliampere. We have number 7, which is 8.4 over 100, divided by 100, 0.084 milliamperes. And the last one will be 10 divided by 100. That will be zero point 0.1, which is again exactly the same with the zero point 0.1 milliamperes or zero point 0.1 milliampere that you see here in the limit. So again, the rule is if your selection is in the zero point 0.1 milliampere, you read from 0 to 10, but you have to divide your answers by 100 to get the accurate result. Now let's see the next one. Let's try to think that our unit will be microamperes. So we will think of the 10 here as 100 microamperes because we have chosen this zero point 0.1 milliamperes also. But instead of thinking about milli, we will think of it as micro. And to do that, we have to make it 100 microamperes. Again, you cannot think of this as 100 right now. To make this 100, we have to multiply 10 by 10. Therefore, all our readings this time will be multiplied with 10. So our limit is 100 microamperes, but we will read from 0 to 10, but multiply it with 10. Again, ignore or do not look at the top. Just look at the bottom. Let's try the first reading. The first reading is zero point 0.2 multiply with 10, 2 microamperes. The third is zero point 0.9 multiply with 10, 9 microamperes. The fourth, 2.8 multiply with 10, 28 microamperes. 6.4 multiply with 10, that will be 64 microamperes. 7 multiply with 10, we get 70 microamperes. 8.4 multiply with 10, we got 84 microamperes. And 10 multiply with 10, we got 100 again, which is exactly the same with our limit. That's why we know that our answers are correct as long as it's lower than 100. Now, if you have written more than 100, I'm sure you're wrong. Although you may also be wrong if it is lower than 100, you have to be careful in looking at the divisions. Now let's try zero point 0.1 amperes or zero point 0.1 ampere. What will happen here? We will still read from 0 to 10, but this time we will divide our readings by 100 because 10 is not the same with zero point 0.1. To make this 10 to become zero point 0.1, we have to divide it by 100. That's why all of your readings here will be divided by 100. Like the first one, or number 2, zero point 0.2 divided by 100, that will be 0.002 amperes. Or ampere, and zero point 0.9 will become 0.009 ampere. 2.8 will become 0.028 after division to 100. We have 6.4, it will become 0.064 ampere. We have 7, it will become 0.07 ampere. We have 8.4, it will become 0.084 ampere. And lastly, 10 will become 0.1 ampere, which is equal to the zero point 0.1 ampere here at the limit. Now, how about the 100 milliamperes? What do you think will we do? For the 100 milliamperes, we cannot think of 10 as 100. Therefore, we have to multiply our answers by 10. So all of the answers here from 0.2 will be multiplied with 10. So zero point 0.2 multiply with 10, that will be 2 milliamperes. Zero point 0.9 multiply with 10, that will be 9. 2.8 will become 28 milliamperes. 6.4 will become 64 milliamperes. 7 will become 70 milliamperes. 8.4 will become 84 milliamperes. And 8, number 8, 10 here will become 100 after multiplying our answers with 10. Again, when the DC current is at 100 milliamperes, we have to read from 0 to 10 and we have to multiply our readings with 10. That's why using analog meters are more difficult than using the digital meters, because in the digital meters the answers will just be read. It's already there on the screen of the digital meter. Anyway, let's move on with the 1 ampere limit. If you do the 1 ampere limit, then this will not be 1 ampere. We have to divide this by 1, but not by 1, by 10. And so all our answers here will be divided by 10. So in this example, we are using the 1 ampere limit, and we will be dividing our answers by 10. And our answer here will be zero point 0.2 divided by 10. We will get 0.02 amperes. And the next one, zero point 0.9 will become 0.09 ampere. 2.8 will become 0.28 ampere. 6.4 will become 0.64 ampere. 7 will become zero point 0.7 ampere. The next one, number 7, will be 8.4 divided by 10. We will get 0.84 ampere. And then the last will be 10 divided by 10. We will get 1 ampere. Now let's move on to, let's summarize that one. Again, if you selected the 1A or 1 ampere here, what will you do? You will read from 0 to 10 at the bottom, and you have to divide your answer by 10. How will you know if you will multiply or divide? Just look at the limit. If the limit is 10, how will it become 1? We have to divide 10 by 10. That's why we divide by 10. Now let's move on with the same current meter, but this time still on the 1 ampere selection, but we will be thinking about 1000 milliampere amperes as our limit. But this time, this is 10 only, and to make it 1000, we have to multiply by 100. And so, we will be getting answers multiplied with 100. Instead of zero point 0.2, we will be getting 20 milliamperes. The zero point 0.9 multiplied with 100 will be 90 milliamperes. And so on with the others. 2.8 will be 280 milliamperes. 6.4 will be 640 milliamperes. 7 will become 700 milliamperes. 8.4 will become 840 milliamperes. We have the 10 will become 1000 milliamperes. So that's it for the 1000. And lastly, we have the 3A or the 3 amperes limit. And because we put our selection to 3 amperes here, we will now be using the top scale again. We will not use 10 because this is 3. Because this is 3A, the limit is 10 here. We cannot use 10. We will be using 30, but we have a problem because 30 is not 3. Therefore, we have to divide 30 by 10 to get it to make it 3. So all of the readings at the top scale, again, as we have done in the previous example, we have to make it zero point 0.5 for the small lines and 2.5 for the big lines, and we will be getting 0.5 divided by 10. We will get 0.05 ampere. We will get the zero point 0.5 will be 0.05. The 2.5 will be here. This is zero point 0.5, and this will be 2.5 in the middle of 0 and 5. Multiply or divide with 10 by 10, we got 0.25. The number 4 is 8 divided by, because this is 7.5 plus zero point 0.5, that's 8 divided by 10, we got 0.8. 19.5 will become 1.95. 21.25 will become 2.125. Number 7, which is 25.25, will become 2.525. And lastly, the 30 here, 30A or 30 amperes will become divided by 10 will become 3 amperes, which is exactly the same with the limit. So, if you write here 30, you will be wrong because 30 is bigger than 3, which is the limit. And so that's it. That's the end of our presentation for today about how to use the analog multimeters with the analog voltmeter and the analog ammeter. So please subscribe to this channel and thank you so much for giving your time in listening and watching our video tutorials. Have a nice day, everyone.